Hi everyone. We were talking in this class. We will be talking about specials. So we talked about factoring, and we in the past we factored. You would take a trinomial and turn it into something you could factor. And then I said, well, next we should always be looking for a GCF. So if there's something we could take out, like a GCF in this case, the red question was 14, 12a squared v minus 54av minus 30v. And I said, hey, we should look to see if there's any number or variable or combination we can take out of each term. And we did that. So we spent a day on that as well. But you always look at GCF first. Next, we look to see if you can factor it. So taking it to the next level, and this one's factorable, you should be able to look to see if they're factorable after you take something out. Here's one. You take out a 3, and then you're here, and you can actually factor v squared minus 9v minus 10. So the final answer means when it says factor completely, the final answer is you go all the way. So today we added one more wrinkle, which is number one, you always look to GCF. Number two, you should look to see if there's a special. So specials are these 5 specials that we went over. We're only going to concentrate on 3 because the difference of 2 cubes and sum of 2 cubes we're not going to get to. But here are the formats. A squared plus 2xy plus y squared is ax xy squared. Same thing with minus, it's x minus y squared. And then we have my favorite one here, which is the one we're going to spend the most time on, which is difference of 2 squares, not sum of 2 squares. So let's talk about these specials and how they apply. So I made a couple examples over here to show you exactly what the specials look like. So first off, when you have two that are right off the bat, just a regular everyday problem is the first 2. So let me show you. So what I'm doing when I factor these is I say, oh, x plus 3, x plus 3. That's a perfect square and that's a perfect square. When you start noticing the specials, you'll start being able to write your answer as x plus 3 squared. That's a special because the answers are the same. Same thing with this one. It's going to end up being x minus 2 squared. It's a pattern. The next pattern is called difference of 2 squares. That's special 1, special 2, special 3 is this guy. W squared minus 16 is just like the third special, which is x squared minus y squared equals x minus y, x plus y. This one's going to be, the perfect square is w, so you put w's and you put 16, is really 4 and 4. I asked people as we went through it to check. So we tried this one and said, is 25 a perfect square? Yeah, 5 and 5. 16n squared is a perfect square, 4n and 4n. And when you check, the middle terms of FOIL cancel them out. Here's another good example. You GCF out the 2 and you can now use the special. It's almost like we were factoring trinomials before, 3 terms. Now when you get the 2 terms, it's actually factorable now using difference of 2 squares. This one is a unique one. See how these are perfect squares? So it's 3x and 5. But if you were to set this up, it is actually not factorable because it's not called sum of 2 squares. It's called the difference of 2 squares. So this one is actually not factorable. So if you checked it, you would find out that this does not give you the original equation when you FOIL. Last but not least, the last one I didn't even get to in some of the classes, but I'm going to show you. So what happens when you have m to the 4th minus 16? So m to the 4th minus 16, those are perfect squares. So you get m squared minus 4, m squared plus 4. Now, you think you're done. You took the perfect square, but you're not. This one is a perfect square too, so you can actually keep going. This is typically a problem I'll give on a bonus on the quiz, and then maybe I will put it in usually on a test. But just so you can see it, the final answer is way longer than you typically would have, but it does work.